What if you woke up tomorrow and your bedroom window faced a mountain that never existed before? What if your memory said your best friend's name was Adam, but everyone else swore it had always been Aaron? You'd think you were going mad. But what if you weren't? What if you had slipped, just slightly, into another version of reality? We've always assumed reality is singular. One timeline, one world, one set of rules. But what if that's just an illusion, a comfortable lie evolution crafted so our brains wouldn't shatter under the truth? Because the latest in quantum mechanics, relativity, and neuroscience all hint at one terrifyingly beautiful possibility. We may not live in a single unified reality at all. The cracks in the wall. You might think reality is stable, solid, but physics says otherwise. At the smallest scales of existence, the quantum level, particles don't behave like billiard balls. They shimmer, they blink, they exist in multiple states at once, a phenomenon known as superposition. They only choose a state when observed. This means the reality you experience could literally depend on what you're observing, or who's observing it. So what does that make of your world? Is it selected? Rendered? Your brain, the reality filter. Neurologists have long agreed what we see, what we hear, even what we remember, is filtered. Your brain isn't showing you the raw truth. It's giving you a simulation that's good enough to survive. Just take a look at your blind spots, literal zones in your vision where your brain fills in details that aren't there. Now stretch that idea. What if all of reality is a fill-in? A story your consciousness is narrating in real time from something much deeper, stranger, and multidimensional. The ancient echoes of many worlds. The idea of multiple realities isn't new. The Hindu Vedas spoke of lokas, layered worlds existing in the same space, vibrating at different frequencies. Australian Aboriginal cultures talk about dream time, a parallel world that exists alongside ours. The Mayans mapped time as a spiral, not a straight line, suggesting they believed in repeating cycles, echoes of different Earths stacked on top of each other. Even ancient mysticism seems to whisper, this world is just one of many. Modern physics joins the chorus. In 1957, Hugh Everett proposed the many worlds interpretation of quantum mechanics. It was ridiculed until it wasn't. Now, it's one of the leading theories in physics. In Everett's view, every time a quantum event occurs with multiple outcomes, the universe splits, not metaphorically, literally. That means right now, somewhere out there, there's a version of you who never watched this video. Another one who became a pilot. One who died in 2012. One who never existed at all. And the freakiest part? Some physicists believe these versions might not be entirely separate. Entanglement, reality's secret thread. Imagine two particles created together, then sent billions of light years apart. Change one and the other changes instantly. This is called quantum entanglement, and it breaks all the rules we thought we knew. Einstein called it spooky action at a distance. But what if it's more than spooky? What if entanglement is a thread not just between particles, but between realities? What if your dreams, your déjà vu, your gut instincts are echoes from another you, living another life right beside you, just one frequency away? The illusion that keeps you sane. Why don't we see these other realities? Why can't we step into them like opening a door? Maybe it's because we're not built to. Think of a radio. It only plays one station at a time. The others are still out there, broadcasting, but you can't hear them unless you tune in. Your brain, it's your tuner. What if altered states, deep meditation, trauma, psychedelics, momentarily twist the dial? The journey begins. This is just the beginning. In the chapters ahead, we'll explore real theories on how wormholes could be used to travel between timelines, why time isn't what you think it is, how consciousness may be the very thing holding parallel realities together. You're not just watching a science documentary, you're taking a guided tour into a mirror maze of existence itself. And by the time this is over, you won't just question what's real. You'll question which version of you is asking that question. Imagine folding a piece of paper in half. On one side, you mark point A, on the other, point B. Now, pierce a hole through the fold so A touches B instantly. That, in the most basic sense, is a wormhole, a hypothetical tunnel in the fabric of space-time. A shortcut that could connect two vastly distant points in the universe, or two moments in time, or perhaps even two parallel realities. But here's the twist. This isn't just a sci-fi fantasy anymore. It's rooted in Einstein's own equations. Einstein, Rosen, and the birth of the bridge. In 1935, Albert Einstein and physicist Nathan Rosen discovered a peculiar solution in the equations of general relativity, one that allowed for what we now call an Einstein-Rosen bridge. Two black holes connected by a tunnel, a bridge across space-time. But back then, it was only a mathematical curiosity considered unstable, impossible to cross, and destined to collapse the moment anything entered it. Still, the seed had been planted, because even if we couldn't cross it, the math suggested that nature might allow it. Stability problem, why wormholes collapse. Let's say, hypothetically, a wormhole exists. You jump in hoping to emerge light years away or thousands of years in the past. Here's the bad news. According to classical physics, it would collapse faster than the speed of light, crushing you inside. The walls would cave in, the tunnel would snap shut like a mousetrap. But physics never gives up that easily. What if something could hold the wormhole open? Enter exotic matter. To stabilize a wormhole, you'd need something stranger than anything in the periodic table. Something with negative energy. Not just low energy, negative. In theoretical physics, exotic matter refers to material that violates the energy conditions of classical relativity. It has negative mass. It would literally fall upward in a gravitational field. And here's the kicker. Such material might exist. We see hints of it in the Casimir effect, a quantum phenomenon where two plates placed close together in a vacuum create a measurable force due to negative energy between them. It's tiny, but real. Enough perhaps to suggest wormholes aren't just possible, they could be engineered. Kip Thorne's wild experiment. In the 1980s, physicist Kip Thorne, yes, the same mind behind the science of interstellar, took this further. Thorne and his colleagues developed detailed equations describing traversable wormholes, using exotic matter as the stabilizer. Their question wasn't if wormholes could exist. It was, could a civilization ever build one? Answer, theoretically, yes. Thorne even designed a wormhole where one mouth is accelerated near the speed of light, then brought back, causing time dilation. The result? A tunnel through space and time. Yes. A time machine carved into the universe itself. Navigating the tunnel, risks and paradoxes. Let's say we had the tech. The wormhole is stable, traversable, you're ready to step inside. Now what? Would you really emerge on the other side? Or is there more going on? Some physicists propose that if wormholes do exist, they wouldn't just link points in our universe, but possibly entirely different universes. In that case, walking through one wouldn't just be a shortcut, it would be a dimensional shift. And that introduces some serious paradoxes. What happens if you go back and change your past? What if the other end of the wormhole is in a universe where you never existed? Could you collapse both realities just by entering? These aren't just storytelling devices. These are active questions in theoretical physics right now. Are wormholes already out there? So far, we've never seen a wormhole. Or have we? Some black holes exhibit properties that defy conventional understanding. Their cores may not contain singularities, but portals. Some gravitational lensing anomalies suggest light might be bending around something hollow. And some physicists have proposed that certain repeating radio signals, known as FRBs, fast radio bursts, might even be signs of wormhole activity, interdimensional echoes flickering through space-time. Still speculative, but worth watching. Aliens and wormhole engineering. Here's a tantalizing thought. What if advanced civilizations already harnessed wormholes? According to the Kardashev scale, a Type 3 civilization would be capable of manipulating energy across galaxies. For them, building or stabilizing a wormhole might be like building a tunnel through a mountain. Not impossible, just technical. And if that's true, it raises a haunting possibility. Maybe aliens haven't contacted us because they don't travel across space. They tunnel around it. Wormholes, portal, or prison. But there's a darker side. What if a wormhole could also be a trap, a self-replicating loop, a structure that folds you into infinite versions of yourself, a cosmic mirror maze? Would you know if you ever left the tunnel? Or would you wake up in a world 99.9% like yours, with one detail just slightly off? Would you even remember? End chapter. Messaging. So now we ask, if wormholes can exist and do exist in theory, what are we waiting for? Because in the next chapter, we'll confront the second part of the equation. Time. It flows forward, but does it have to? Could we use space-time tunnels to not just move across galaxies, but across hours, years, and eternities? Time isn't what you think. We live in the illusion of time. We wake up, we work, we age, we die. But what if that entire process, our arrow of time, isn't a law of nature, but a trick of perception? What if the past, present, and future all exist simultaneously, and our minds are just riding a wave through a cosmic ocean where nothing ever really moves? In this chapter, we dismantle your entire idea of time, because physics doesn't just bend time, it unbuilds it. Time is not a universal clock. We like to think of time as something absolute, ticking away in the background like the beat of a cosmic metronome. But Einstein shattered that idea. He showed that time is relative. It flows differently depending on your speed and gravitational environment. This isn't theory, it's proven. Put two synchronized atomic clocks side by side. Leave one on Earth and fly the other around the planet in a high-speed jet. When they reunite, they're out of sync. One has literally aged less. This isn't magic, it's time dilation. The twin paradox, a real-life time machine. Let's go deeper. Imagine two identical twins. One stays on Earth, the other boards a spaceship and travels near the speed of light, then returns. According to relativity, the space-traveling twin would have aged significantly less. This is called the twin paradox, and it's not science fiction. It's a direct prediction of Einstein's special relativity. At high velocities, time slows down relative to stationary observers. So technically, we already know how to travel to the future. We just need to go fast enough. Gravity can bend time. Here's the part that breaks minds. Not only motion, but gravity itself warps time. The closer you are to a massive object, a black hole for example, the slower time passes. This is called gravitational time dilation. If you hovered near the event horizon of a black hole for a few minutes, then returned, hundreds of years could have passed on Earth. That's not science fiction, that's general relativity. And if that's true, then past and future become entirely relative. Is time a loop? Einstein didn't believe in a past or future. He once said, the distinction between past, present, and future is only a stubbornly persistent illusion. But modern physics has gone further. Certain solutions to Einstein's equations, like Gödel's rotating universe, allow for closed time-like curves, loops in space-time where you could return to your own past. In essence, time loops are mathematically possible. So why haven't we seen time travelers? Maybe we have, and we just can't recognize them. Or maybe time travel doesn't look like what we imagine. Block universe theory. All time exists at once. Let's get radical. In physics, there's a theory called the block universe. It says the past, present, and future already exist. All of them, right now. Your birth, your death, the end of the universe, every version of you in between. They're all there, like frames in a film reel. And you're simply experiencing them one by one. From this view, time doesn't flow, we flow through time. And wormholes? They might just be ways to skip forward or backward along the reel. But what if you could jump off the film entirely? Chronons. Is time quantized? Some scientists propose that time isn't continuous, but made of indivisible units called chronons. Like how matter is made of atoms, time might be made of tiny time particles, a minimum tick that can't be broken. If this is true, then time might not just flow, it might refresh, frame by frame, like a simulation. Think about that. What you call now may just be the latest snapshot your consciousness is viewing before moving on to the next. Deja vu, dreams, and time loops. Have you ever had a dream about something and then it happened? Ever felt like you've lived this exact moment before? These experiences are often dismissed as mental glitches. But what if they're leaks? Little tears in the fabric of time where your consciousness slips out of sequence, previewing moments from alternate timelines or revisiting previous frames of your own life. If the block universe is true, then déjà vu isn't a mystery. It's a memory of something that already exists in another slice of space-time. Consciousness and the perception of time. Now ask yourself, why do you perceive time at all? You're not a clock. You don't tick. Your brain doesn't feel time. It creates the illusion of time to organize sensory input, which means time isn't something you travel through. It's something your mind builds, second by second, to make sense of the ever-evolving now. But what happens when your mind changes? Through meditation, trauma, psychedelics, people often report timelessness or even glimpses of other moments, as if consciousness itself transcended time. End of chapter. Message. So what is time really? A flowing river, a loop, a static landscape, or a simulation your brain constructs to keep you from going mad? The deeper you dive, the less certain the answers become. But one thing is clear: if time is relative and can be bent, stretched, or looped, then reality itself is not anchored. And in Chapter 4, we'll go even further into the most disturbing idea in modern science: quantum entanglement, and the possibility that your reality is being entangled with another right now.